So I'm Brittany,
And I'm Hannah.
and we did calculus in Tangled the movie.
Okay, so, the reason we chose it is because we both really like Tangled, and we both really like Disney, so we thought that it would be a fun project to do if we're doing something that we enjoy looking up. And I watched the movie as part of my homework, so that was fun. Okay, so the history of Tangled starts off with the Brothers Grimm tale of Rapunzel. And it's a little bit different than if you've seen the movie Tangled. It starts off with a couple that lives like in the forest next to like a witch. And the couple is expecting their child, and the wife becomes really hungry for this Rapunzel plant. And so the husband goes over the wall into the witch's garden, to the witch's house area, and he takes the plant from her. And so on the third night, the witch finally catches him, and she basically tells him, hey, I'll let you off loose if you give me your daughter when she's born. So the guy's like, yeah, sure, I'll do that. And so when Rapunzel was born, the witch locked her up in a tower. And so when she was 18, this is kind of all going down when she's 18, and so the witch comes in and says, Rapunzel, Rapunzel, let down your hair, and that's how she enters in and out of the castle. And so Mother Gothel leaves as she pleases. And so one day, there was a prince that came wandering in the forest, and he heard this beautiful music from Rapunzel that was singing up in the tower. And so Rapunzel, Rapunzel, let down your hair, and he kept on going up and visiting her. And then on the third day, Mother Gothel found him in the tower, so she pushed him out, and he fell on some prickly bushes, and he was blind. So that's a little bit scarier than the actual movie. But, so now Rapunzel runs away. Prince is walking aimlessly through the forest, blind, and so a couple months go by, and the prince hears beautiful singing again, so he follows the voice, and he comes to Rapunzel, and Rapunzel heals him with her tears, and they live happily ever after. So, yeah. So now to start off, this is the actual movie that's cuter and not as scary, but we found the rate of growth of Rapunzel's hair, because she has really long hair. And so Rapunzel's hair is 70 feet long, that we've learned in the movie and from the other tales and such. And so in the movie, she's 18 years old. It's her 18th birthday. So we researched and found that average hair growth is 6 inches per year. And so if her hair would grow 6 inches per year like a normal person, and it would grow nonstop since she was born, and she wouldn't cut it, her hair should only be 9 feet long. But it's not. Her hair is 70 feet long, and so on the other end, she should be 140 years old if her hair is 70 feet long. And so to find her rate of hair growth, we just divided 70 feet by 18 years and got 3.9 feet per year is how fast her hair grows. Okay. Now for our second problem, we found the volume of Rapunzel's tower. And a little bit of history of the Riemann sums and the disk method, of which we use to find the volume. Riemann sums are named after Bernhard Riemann, a German mathematician that made many contributions to mathematics. And it's a type of integral calculus, as well as the disk method is a type of integral calculus. And so Sir Isaac Newton, kind of the founder of calculus altogether, furthered the research with 3D figures.
All right, so the history of integration. Archimedes found formulas for the surface areas and volumes of solids such as the sphere, the cone, and the paraboloid. His method of integration was remarkably modern, considering that he did not have algebra, the function concept, or even the decimal representation of numbers. You guys can probably imagine how hard that would be, since now we have calculators. Leibniz and Newton independently discovered calculus, as Hannah said. Their key idea was that differentiation and integration undo each other. Using this symbolic connection, they were able to solve an enormous number of important problems in mathematics, physics, and astronomy. Gauss made the first table of integrals, and with many others, continued to apply integrals in the mathematical and physical science. Cauchy took integrals to the complex domain. Riemann and Legault, or whatever, put definite integration on a form of logical foundation.
Okay, so we researched the height of Rapunzel's tower to be 73 feet tall, which would make sense since her hair is 70 feet long. It kind of needs to go down to basically the floor to crawl up. But for, you can go to the next slide. But I'm also a visual person, so I had to draw it out and label all my stuff. But I only made it 70 feet tall so that I could get increments of 10 and go up to 70. And so I kind of just made my own interval chart, so by 10, 10, 10, and so all I did was take my little handmade ruler and go up and just measure all along the lines of this graph right here. And so we used right Riemann sum, left Riemann sum, and midpoint Riemann sums. You can go back.
It's fast.
That'd be good. And so, yep, we had intervals of 10 to 70 divided by 7 for all of them. And so this one was the right, left, and the midpoint. And you can see that once we solved it all, this is a considerably different amount of area, and the midpoint is usually a little bit more accurate. So all we did was added the 3 areas divided by 3 to get an average of 358.333 feet squared, which is the integration from 0 to 70 of our f of x. And so this is me at Disney World last summer, so Rapunzel's Tower. But we took then by this method, so we just had to multiply this by pi because we just found this in the other problem. So we took the 358.333 pi, which equals 1,125.736 feet cubed. And that is the area of Rapunzel's Tower, not counting the little 3-foot tower thing on top. Volume.
Alright, so next we went to find the angle of elevation of the floating lanterns. One specifically was the parents let off one. Play it? Okay, so the parents is letting off one lantern, and it eventually comes back to Rapunzel, who's sitting in the boat with Flynn. And Rapunzel, we guessed, is sitting approximately 450 yards away from the castle. And we took the 450 yards divided by 5 seconds, which is about how long this clip is, to find the rate of 2.514 yards per second. And then we drew kind of a little triangle to show you what it's like. And so our rate, like I said, is 2.51 yards per second. And we're trying to find the rate at which the angle is changing. And we know to find that angle, we need to use tangent, which is y over x. And then we took the derivative of the function tangent equals y over x, and we know that the derivative of tangent is secant squared. And then we took the derivative of y over x using the quotient rule, and then we were able to plug in our points from there, which we have the rate, which is 2.514, and then x and y. And then we know that the rate of which the distance is changing is 0 because it's staying constant. And so from there, we found that the rate of change of the angle is 0.0052 radians per second.
Yeah, as much as I'd like to watch the rest of it. Okay. Our next problem we looked at was the velocity of Flynn Rider, and there's a video clip on this one. And actually, if you skip to in the middle, that's where it happens. But when I was watching this clip, it kind of gave me an idea. You'll see. I'll just let you play from there. No, it's go back.
Oh.
Go back. Keep going.
Right here?
Yeah.
Oh,
That's good.
Okay.
That's good. And get rid of the you don't need something this either. But as we were watching this, you'll see that. Yeah. Just.
Interesting fact, we looked up the average weight of a barbarian, about 350 pounds.
But he gets launched in the air and he lands on Maximus. And I thought that was pretty cool, and I was wondering how fast. That was about 5 seconds it took him for that. So again, as much as I'd like to watch the rest of it. But the history of velocity.
The first scientist to measure speed as distance over time was Galileo, and then Sir Isaac Newton and Gottfried Leibniz are created with the invention of differential and integral calculus, also known as the position function, velocity, acceleration, derivatives, and integrals. And this was around the late 1600s.
And so back to the last problem. He's only launched a smaller distance, but we thought, hey, wouldn't that be cool if he were to be launched completely over the castle and land on Maximus in 5 seconds? And so we had to find the distance of the castle. So we looked up a little bit about like how the animators created it, and we found that they based the castle in Tangled off of Le Mont St. Michael in Normandy, France, an actual castle in France. And so we found that the height was 155.5 meters above the sea level, which we used in the lantern problem, and that the circumference was 960 meters. And so we just divided by pi to find the diameter or like the distance of the castle.
Alright, so then to find Flynn's velocity, we can take that diameter divided by the 5 seconds, and we got 61.1154 meters per second. And then to find the acceleration, we took that velocity divided by the time interval again to get 12.223 meters per second squared. Then we were interested on what it would be in miles per hour, so we found that. And his velocity would be 136.597 miles per hour. Imagine how fast he's going. Probably not realistic, but it's okay. And his acceleration is 98,271.223 miles per hour squared.
Well, and also considering that we did this in 5 seconds, he probably would not be launched over the castle in 5 seconds. Okay. And then our last problem wasn't off of the movie, but I was inspired by it on my trip to Disney last summer. And waiting in line to meet Rapunzel, I was looking forward to calculus in the fall, and I'm like, this is going to be so great. What we're going to do with problems like this, it's going to be wonderful. So we did our next problem on this.
Alright, and to go over the history of the trapezoidal rule, it's the first Newton-Cotes quadrature formula, and Roger Cotes made advancements in the theory of logarithms, the integral calculus, and in numerical methods, particularly interpolation. It set the foundation for integral and differential calculus.
And
as said before.
calculus,
Yeah.
and this is basically like the Newton-Cotes is basically the trapezoidal rule. So what I did is I went online and I found the standby wait times, because Disney kind of has a list of all that stuff online. But this is about like the time of wait times, and I actually found this just today. So this would be like what you'd be waiting at today. And so like lines open at 9 o'clock in the morning and they end at 10 p.m. And so then I just created a table of what I found up there. And so when I was in Disney, I waited for Rapunzel at about 12:30 in the morning. And so I just wanted to find the rate of time at which like the minutes would be increasing. And so I just went in between, 12 o'clock and 11 o'clock to find an average. It's increasing by 4 minutes at that time for the rate. And then for average wait time, we just took the trapezoidal rule. And so I took 13 minus 0, which is the time of all of this, and divided by 13, which is the amount of intervals I have, and then divide that by 2. And then just took all of my numbers and plugged them in, and got an average wait time of 376 minutes is the average wait time between 9 a.m. and 10 p.m.
Alright, so that wraps up our presentation. Hope you guys liked it.